Let's explore magnitude comparators. The topic for this presentation is comparing binary numbers for equality and magnitude using digital circuits. A magnitude comparator is a combinational circuit that takes two binary numbers as input and determines their relative magnitude relationship. It determines whether the first number is equal to, greater than, or less than the second number. There are three types of comparisons that a magnitude comparator can perform. These are equal to where A is equal to B, greater than where A is greater than B, and less than where A is less than B. Here is a truth table and the equations for a one-bit comparator. The table shows all possible combinations of inputs A and B, and the corresponding outputs for A equals B, a greater than B, and a less than B. The equations derived from the truth table are A equals B is equal to a prime B prime plus AB, a greater than B is equal to AB prime, and a less than B is equal to a prime B. Now let's consider a 2-bit comparator. Given two 2-bit numbers, A equals A1A0 and B equals B1B0, the logic for determining their relationship is as follows. A is equal to B if A1 is equal to B1, and A0 is equal to B0. A is greater than B if A1 is greater than B1, or if A1 is equal to B1 and A0 is greater than B0. Here are the Boolean expressions for a 2-bit comparator. For A equals B, the expression is A1B1 plus A1 prime B1 prime multiplied by A0 B0 plus A0 prime B0 prime. For a greater than B, the expression is A1 B1 prime plus A1 B1 plus A1 prime B1 prime multiplied by A0 B0 prime. For designing an n-bit comparator, there are generally two approaches. The first is the cascading method, where multiple smaller comparators are connected in series. The second is iterative comparison, where bits are compared bit by bit, starting from the most significant bit, or MSB, to the least significant bit, or LSB. In the cascading flow, the MSB comparator passes its result to the next bit comparator, and so on until the LSB comparator provides the final output. Magnitude comparators have several applications. In microprocessors, they are used for conditional branching and decision-making. In digital signal processing, they are used for signal amplitude comparison. And in memory systems, they are used for address comparison and sorting. In summary, magnitude comparators are combinational logic circuits, so no memory elements are required. Their design is scalable, meaning they can be extended to any bit width. And they provide three outputs: equal, greater than, and less than. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.